everyone. My name is Alicja Fraś, and I come from Poznań University of Economics and Business in Poland, and I'd like to share with you some of the solutions that I found to the problems that I encountered performing calculations for my PhD thesis. Very often during the analysis, I had to go through the columns and then apply some specific functions on the rows, sometimes with moving windows or between some groups of rows. And my specific data set looked like this. I had a number of mutual funds. It was more than 1,000, and the daily rates of return. And what I needed to do was calculating the average rate of return within each week of the year for each fund. So the first solution that came to my mind was using the for loop and go across all the columns, and then I used the aggregate function for each column to calculate the mean across the week numbers. However, this solution was quite time consuming, and I came up with another solution. I think a smarter one. It looks cleaner. It's the first thing that we see. And so I used the apply function across the columns and then used tapply within each column to aggregate across the week numbers and use the mean function. So the result was actually the same in both cases. However, the execution times that I measured with micro-benchmarked package was almost 3 times faster than the case of the for loop. The next thing I needed to calculate for the thesis was the value at risk. And for those of you who don't know the concepts, like simplifying, having the distribution of my rates of return, the value at risk at 5% would be the cut off the borderline when I cut off the 5% of the worst cases. And what I also needed to have was the moving window. So I calculated the value at risk for the last week of the year, basing on the whole year, and for the one before, using the observations moved by 1. And when I applied the for loop solution, I went again through the columns and through the rows, applying the index from 1 to 52 and using the value at risk formula. And the other solution with the apply function. So I have the apply function, and for along the columns, and within each column I have the sapply with the indexing 1 to 52. So I have the moving window, and again the result was the same. However, the execution time went down 3 to 4 times compared to the for loop. And the third issue I'd like to present you was I needed to differentiate which of the funds were evaluated daily and which were weekly. So it boiled down to the question which of the funds within 1 week have more than one non-zero rate of return. If they have more than one, it means they are probably evaluated daily, because if there is only one non-zero rate of return and there is a 0, probably there is only 1 day when the rate of return changes, so they are evaluated weekly. So how I did it with the for loop, again, the for across the columns, and then the aggregate function. So I have the summation of the number of the days within a week where the rate of return is different than 0, and with the apply function, I have the apply along the columns, and then the tapply to some non-zero rates of return within each week. And the execution time is more than 3 times faster in this case, and it really helped me to shorten the time of performing my calculations. And that's all I wanted to show you. I hope you will find it useful and enjoy your lunch.